throughout the universe. They're enormous balls primarily composed of hydrogen, the most abundant element in existence, and helium. Other types of gaseous planets do exist. Uranus and Neptune, for instance, are ice giants because they're made of heavier elements like oxygen and carbon. The term gas giant once included these ice giants until we learned more about their distinct composition. Ice giants are also much colder than gas giants, with core temperatures reaching around 12,600 degrees Fahrenheit versus Jupiter's 43,000 degrees Fahrenheit. Jupiter's core is almost 5 times hotter than Earth's in comparison. And though gas giants are generally light, Saturn would float if you put it in a big enough body of water. Gravity still means that they get crushingly dense the further into one you were to fly, just like depth pressure increases the deeper underwater you are. This, combined with toxic gas, deadly storms, and soaring temperatures, mean that gas giants have been written off as far as our search for alien life is concerned. In our studies into exoplanets, astronomers usually focus on the most Earth-like exoplanets they can find. The more similar a body is to Earth, its size, how close it is to its star, the composition of its atmosphere, and so on, the more likely it seems to us that it could support life. This could either be alien life of its own or human life if we develop a way to travel to exoplanets one day in the future. But while we romanticize Titan's Earth-like atmosphere and Europa's subsurface oceans, we might be ignoring the potential of their parent planets to host bizarre life forms we can't even begin to imagine. Weird as gas giants are, they're definitely more Earth-like than we give them credit for in a lot of ways. They might not be rocky planets, but Earth isn't entirely made out of rock anyway. More than 70% of Earth's surface is covered by water. We have immensely deep and vast oceans that support some of the strangest creatures on our entire planet. Just like gas giants now, the deep sea was once thought to be extremely inhospitable to life. That all changed in 1977, when giant tube worms were discovered in the waters around the volcanic Galapagos Islands. These worms definitely look like they could have come from another planet, and they live around sulfur-spewing volcanic vents in temperatures around 700 degrees Fahrenheit. Since then, other extremophiles have also proven their durability. In 2007, tardigrades managed to survive a trip to outer space. For 10 days, they were exposed to a vacuum and/or solar radiation. While the radiation killed off many specimens, a few survived. Those who weren't exposed to radiation fared much better, while conditions inside the gas giants would be much different. These discoveries have shown that organisms can survive in much more extreme environments than we once thought. So could Jupiter have its own never-before-seen life forms akin to the giant tube worms? Or larger animals like any of the unusual gigantic creatures that live in the relatively unexplored deepest parts of our seas? Again, just like the sea, the upper parts of Jupiter's atmosphere could be thick enough to support life without crushing it, leading to creatures that float through the clouds in the same way as a fish swims through the sea. Two of the most famous and influential physicists of all time, Stephen Hawking and Carl Sagan, suggested that life could emerge just like this on a gas giant. Sagan's hypothesis came before much was known about the composition of Jupiter's atmosphere. But the conditions there are only hostile if we assume that all life in the universe is carbon-based and flourishes in the same way we do. Since we've never found alien life, it's impossible to say whether the only life the universe can produce is carbon-based or whether anything like hydrogen can form the basis of a planet's ecosystem. Sagan went into the most depth about this idea and provided plenty of material for budding science fiction authors to get inspired by. He suggested 3 main types of organisms that could live in the Jovian clouds: hunters, floaters, and sinkers. Sinkers are small prey animals that make up the food of both hunters and floaters, while hunters are the apex predators. Though they would live in what we usually think of as the sky, they would have far more in common with sea creatures. Just like fish, they would be perpetually suspended, floating forever through the clouds. Floaters are the most emblematic of this idea. They would be enormous biological balloons, which might sound strange, but they would actually be a lot like jellyfish, but unfathomably huge jellyfish, the likes of which we've never seen on this planet. A hunter could take the form of any oceanic predator, from a killer whale to a deadly stingray. Throughout sci-fi, we've already imagined space whales in everything from Doctor Who to Star Wars. If we can imagine that a space whale might somehow exist, we can definitely imagine something similar lurking in Jupiter's gaseous seas. On the other hand, a theory posited by physicist Erwin Schrödinger might suggest that Jupiter is simply too volatile for life to form. In physics, entropy is the process by which a system's useful energy decreases over time. While energy cannot be created or destroyed, useful energy can become useless, and the overall entropy of the universe is steadily increasing. In summary, entropy means that order will eventually give way to chaos. But as Schrödinger wrote in his 1944 book, What is Life?, there's also negative entropy, or negentropy, which refers to how some open subsystems can become more ordered over time. Life on Earth is a perfect example of negative entropy, emerging from a primordial soup billions of years ago. However, negentropy is also relevant to gas giants, because there is an argument that the conditions on Jupiter are simply too volatile for order, i.e. complex organisms, to form from the chaos. For order to form at all, there needs to be some basic stability in at least some corner of the system, and the turbulent, chaotic clouds of Jupiter might not meet this minimum condition. Of course, just because Jupiter might not be the ideal location for Sagan's hypothetical creatures, that doesn't mean that another gaseous planet somewhere else in the universe couldn't be. There's no scientific reason why such a planet couldn't be made up of gases necessary to breathe, creating life that's more familiar to us here on Earth. Ice giants already contain many important chemicals for life, including water and ammonia. Life as we know it is built on just 6 chemical elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The only one of these we have not detected in the ice giants is phosphorus. But could the other 5 elements be enough to produce a life form? Perhaps. And just because there's no phosphorus on Neptune and Uranus doesn't mean there's no phosphorus on gaseous exoplanets, especially when it does occur on Saturn and Jupiter. There could feasibly be exoplanets that have a gaseous layer similar to the composition of Earth's atmosphere. If it was denser, it could conceivably support those same creatures Sagan imagined, just like the ocean. We're already looking for ways to survive in the clouds of Venus. Some researchers have proposed that we could build and inhabit cloud cities made up of interconnected ships. And there may already be microbial life there, protected from solar radiation by the thick atmosphere. There are currently several planned or proposed missions to study Venus's clouds further for signs of life. If life and even human habitation is possible in Venus's atmosphere, then it might also be possible on the outer planets too. After all, they might be much farther away from the sun, but they're certainly not cold when you descend far enough into their atmospheres. Perhaps our search for extraterrestrial life has come up short because we're looking in all the wrong places for all the wrong things. And gas giants could have a diverse ecosystem like nothing we've ever seen. And that's why there could be life in